So basically a linear decay or a linear growth simply means that there's a fixed number being added. For example, you start saving and every month you're like, okay, I'm going to save 5,000 rupees every month. So that 5,000 that you're putting in some savings account every month, that is a linear factor. You can easily see that, all right, 10 months from now, I'm going to get 50,000 in my savings, because you have a fixed factor that you can multiply and get your final answer, right? That's the thing. Now, exponential is different. Exponential is when your growth is a multiple or a division of the previous growth. For example, you say, every month I'm going to start by saving 5,000 this month, but next month I'm going to double it, and the next one I'm going to double that, and the next one I'm going to double that. What are you doing? You're multiplying by 2. That's a fixed multiplication factor. So in this case, your growth will be exponential because you're multiplying. And if initially, let's suppose in the first month, your value was 5,000, so it starts at 5K. Now it's going to be 10K the next month, but 20K the next month, and 40K the next month. Do you see that the gap between one value and the other value keeps on increasing now? The gap increases, but over here, the gap is fixed. It is 2 every month. So when the gap is fixed, you're basically adding or subtracting a fixed value. That is a linear growth. And in this case, your growth will be something like this. It'll skyrocket like that. Similarly, if it was decaying, like this is what exponential growth is. For example, the growth of a big bacteria colony, or how does COVID spread? That's all exponential. One person meets 2, that they meet 4, they meet 8, and so on and so forth, just by a factor of 2. So whenever you have a factor multiplying or dividing, that is exponential. And whenever you have a fixed number increasing or decreasing, that is linear. Now, here's the thing. When you have any growth, that is going to go by, but its exponential will also include percentage, by the way, because you are multiplying by 1 point something or 0 point something whenever you're increasing or decreasing. Okay, so we saw that in previous lesson, the percentage decrease or increase. So here's the thing. The linear factor, the equation goes something like this. Y equals mx plus b or plus c. And in this one, you're going to get y equals ax power t. Okay? Or if I were to translate this equation into time, then basically what we're getting is that you have a rate, and that rate is your gradient, which is m. And you have time as your x-axis, so that is t. And your starting value is b. And in this case, your starting value, whenever you start, is b. And then you have a rate. Let's just call it m or something, r. And then you have t. Okay? So whenever t is in the power, that's why it's called exponent, right? So let's suppose something decreases by 10% every month. So your rate is going to be 0.9. Every month is going to be 0.9, 0.9, 0.9. And this b is your starting value, the initial value that you had. In books, they usually use the word a for this. Again, it doesn't really matter, whatever you do. So that's the thing. You can call it mx plus b and ax power t. Doesn't really matter. Your choice, whatever you want to do. Just remember that in exponential growth, there's going to be some multiplicating factor, and it's going to speed up after a while. All right, it speeds up. So for example, over here, the rate is this, over here, the rate is this, over here, the rate is this. The gradient is increasing after a while. But in linear growth, the rate is fixed. Growth is fixed. You are increasing, you're saving by 5,000 every month. That's a fixed value. You're decreasing the phone battery life by 2 hours every day. That's a fixed value. No matter how much time passes, it's going to remain fixed. All right. So linear decay, linear increase, all of that. Of course, if this is positive, then that is growth. And if this is negative, then that is decay or decrease. In this case, if x is more than 1, like if it is more than 1, then that is growth. Because why is it more than 1? Because it's more than 100%. And if it is less than 1, then that is decay. So 0.9 means you're losing 10% every day. Now, another thing that this gives rise to in the linear factor is correlation. And we'll talk about correlation later on. But correlation on the face of it is basically how does one thing affect the other. And correlation is not that they cause one to fall and the other to increase. It's just that, for example, if you have values like this, now you can clearly see that when you go to a higher value on the x-axis, the value on the y-axis falls down. So basically, the correlation of this thing is negative. It's like this. So when you have a line like that, this one, that's a negative correlation, or negative association. That when one increases, the other decreases. But if it was the other way around like this, then it will be a positive correlation or positive association. That when one increases, the other decreases. You can have absolutely no correlation, like something like this. That will be no correlation. You can have strong correlation, in which case you have like this one is stronger than the previous one. They're both positive, but the one with greater gradient is stronger. Okay, so that's the idea of growth and linear growth and all that. So let's try to do a few questions. कोई पूछना कोई सवाल अभी चीज को समझ नहीं आई तो पूछो.
No, sir. I learned correlation from statistics, so I'm good there.
Then you know Pearson's coefficient and all that.
Sorry? Yes, I do.
Yeah, so we are going to keep it very simple. If the initial population of rats was 20, so that's your initial value, okay? And grew to 25, okay, if there's been a change of 5 after the second year. In 1 year, it is, so what's your rate? Rate is 5 rats per year. Which of the following function best models the population of rats with respect to the number of years t if the population is exponential? So here's the thing. What's happening here? The rate is not 5 per year now. It is exponential, which means what percentage is 5 of 20?
25%.
25%. So that means your population is increasing by 25% every year. So your rate now becomes, instead of 5 per year, it's going to be 1.25. 100% of the original one that remains, and 25 extra. Okay, that's our rate now. So it is exponential, not linear. The starting value was 20. So remember, the rate goes starting value times the rate power time. And time is in years now. So that's my answer. Yeah, B. Now, just for the sake of it, let's see what the other mean. P equals to 5t plus 20 means that you're starting with this is your starting value, the y-intercept. And this is your fixed rate. It's a linear growth of 5 every year, which means 1 year is 5, the other year they've added 10, the other year they've added 50. But it's not linear. Okay, what does the third one mean? P equals 20 times 5t. So what it means is that this is your starting value. Okay, so it starts at 20. And 5 means that it's increasing by 5 times every year. Which means first year it's 20, the other year it should be 100. The next year it should be 500. So that's not what it is. And D is basically a quadratic growth, which isn't in our syllabus. So we'll just leave that out. All right. So knowing that, try solving this question. So what's the answer?
Is it A?
I don't know. I'm solving it.
Sir, it's A.
If
Yeah, it's linear, so it's increasing by 25 every year.
Yeah.
And the starting was 100, so you have 125 plus 100. Yeah, exactly. So that one's right.
Sir, is it D?
It's A, sir.
Okay, wait a minute. What's your rate?
It's decreasing by 6%.
It's decreasing by 6%, right? So that means the rate is 0.94 or 94%.
Every 4 years, yeah.
Every 4 years, okay?
Yeah.
So what that means is the time is going to be divided by 4, t by 4. Because if you're doing it for 20 years, you're actually going to apply this 5 times. 20 divided by 5.
It would be
20 divided by 4. So it will be D, the last one. Yes.
Yeah.
So 2 things here. Number 1, and we did it when we were talking about compound interest as well, that you divide by the time you're going to count it for.
सर इसको जरा एक दफा सॉल्व कर लेंगे यहाँ पे बोर्ड.
Yeah, sure. So the first thing is pretty clear that you're starting at a value of 14,000. So that's common in all of them. Then it's saying that the decrease is 6% every 4 years. So your time is not P now, your time is T by 4 because every 4 years the rate is being applied. So it's not t, it's t by 4. So if you were to do it for 8 years, that means you will just apply 2 times. ठीक है, 8 साल में 2 दफा उसने decrease होना ना. So that's fine. And then it's decreasing by 6%. So your rate is going to be, originally is 100%. When it decreases by 6%, that is 0.94. 94% is remaining. That's the rate. Every year, 94% remains. In fact, every 4 years. So that's why the rate is 0.94. So starting value, 14,000 times 0.94 the rate. And the time when you apply this. Clear?
Yes, sir.
What's the answer?
C.
C, yeah. So just keep track of what she's doing. 3, 6, 18, 54. Doesn't really mean like she's giving a fixed value, right? But if you look at the total money that she's received, so first day she got 3, then she got 9, then she got 27, then she got 81. So that is a factor of 3 every time. The total money. And that is what this thing she has received over the course of these 4 days. The question is not about how much money she's giving, it's about the total money that she received. And that's why we will consider these values and they are exponential growth. Yeah, exactly.
Sir, आपसे एक सवाल है.
Yeah.
That's not related to this. Can I ask you?
Sure.
सर मेरा परसों जो है केमिस्ट्री का पेपर है. तो सर आप पढ़ा सकते हैं मुझे?
Okay, so that is how you do this growth questions. I've shared the remaining questions with you, so just go over that. And now we'll talk about proportion. Thing is, we need to speed things up a little bit because we have 27 topics and then we also have to do like 6 exams. And we are kind of short in time. Proportion is basically when you have 2 values. By the way, growth mein koi question hai to pooch lo abhi. Okay, so proportion is related to this. But what we consider this time is that we have 2 values. There is the value, let me call it old value, okay, and there is a new value. And the ratio between them, the new one over the old one, the new over the old, that is your factor. Okay, I can call it K. So proportion is always when 2 things change by a fixed factor, and that factor can be found by finding a ratio of them. That's what it is. That's the idea of proportion. For example, if I say that I have a picture that I want on my phone that I want to hang in my drawing room, and I want that to be 3 times the size of this thing, the original picture, then what that means is that I have to first see what this length is and this length. So if that length was L, this will be 3 times the length. And if that length was J, this will be 3 times J. But the point is that the factor is still the same. It is in proportion to each other. Now, it doesn't have to be 3 because 3 simply means in percentages. What does 3 mean?
3 in percentages would mean 3%, no?
No. 3 times this in percentages would mean 300%.
Yeah, 300%.
Yeah. So when, for example, if I say, all right, now you have tripled it, decrease it by 25%. So then basically what I'm doing is I have already tripled it. So my new length is 3L, but that I'm also decreasing by 25%. So it's going to be 0.75 of that. So my original length is going to be 3 times 0.75, I think 2.25, if I'm not wrong. So there you go. That's it. Now here's the thing. 2 things that are related to each other will affect the value of each other by the relation that they already have. Now let me explain. For example, I have circle. So there's a circular thing and I want to enlarge this circle and make a bigger circle. And that circle, I want to be like, I'm not sure what the new circle is. I'm just saying, okay, radius of this thing, double the radius. Okay, so this is double the radius for some reason. Okay. Now, my question is, how much has the area changed? So we don't really have a connection between one area and the other. But what we do know is that the radius has a connection. So let me look at the old one. If I were to write a formula for the old one, it would be pi r squared. And what's my new one? It's pi times not r, but 2r squared. And that comes out to be 4 pi r squared. And isn't that my old one, this thing. So that means area of new over area of old is 4. So basically, my area is now 400% or 4 times the previous area. And that is the method.
Repeat this one again. I didn't really get
Yeah,
it.
sure. The relation between area and radius was squared, right? So the factor by which the change is also the square of 2, because I squared it. I doubled it, so my area would change by 4. Because that's the relation between area and radius. That's the relation between new area and old area as well. Now, how do we do these questions? First of all, try to figure out the sum expression for original value, the old value. Okay. For example, let's say there's a trapezium here or a triangle here, and this triangle has some height, and now I half the height. How does that change the area of the triangle? Okay, so I've drawn the same triangle but with half the height. How does it change the area? Because it's in proportion, let me see. So first of all, what's the original value? Original value was area is 1 by 2 base times height. Okay. Now let's fix that. That's my old value, 1 by 2 b times h. My new value is going to be 1 by 2 on its own, no relation with that one. 1 by 2, and obviously b is going to be halved. Wait a minute, I didn't half b, right? I just halved h. So b is going to be the same and half h. Okay. Now let's see. This becomes half times b times h. Notice I did not simplify this. There's a reason I did not simplify this. Because now I can fit the original value there. I can see that this thing is my old area. So now I can see that area new is half times the area old. And that is what the proportion is. You always, the method of solving these questions is, you find an expression for the original value, then find an expression for the new value, totally unrelated, and try to fit the original one in there somewhere so that you know the proportion. Most of the time, it's pretty straightforward, but sometimes it helps like this. Do you get the method?
Somewhat, sir. I don't like when you're using different like shapes. I'm not getting it as much, but I understand the general concept.
Haven't you studied geometry?
Sorry?
Haven't you taken geometry?
No, actually, my school never offered it.
That's why. All right, that's fine. I'll try not to. But there is going to be a lot of geometry on my cities.
Yeah, I know.
All right, so we'll fix that. Okay, and proportion questions are mainly asked for geometry. So, okay, so here's the thing. There's a circle and its radius is increased, and I'll just copy the question. The question says, this is my first example. So let's try to solve this question. Do it with me. So the radius of the circle is increased by 25%. Okay, so we have a radius now, and we have increased it by 25%. So what's my new radius?
125%.
125% of the previous one, which is 1.25 r. Okay. Now the method is you find an expression for old value, then you find an expression for new value, then you combine them somehow. By what percent does the area of circle increase? Now, Abraham, the area has this formula. Area is pi is a number you already know. R, the radius squared. That's the area of a circle. Okay. We don't really have to go into how it comes about. It's a pretty straightforward process, but we don't really need to go into that. Okay. Now, this is my general formula. So when I have a value of radius, what's my old value of area? Just plug it in. Pi remains pi. And it's going to be r squared, right? Now, what's my new area? For that, I need to know what my new radius is. Right? I'm sorry?
Wouldn't it be pi 1.25 r squared? The new one.
And the 1.25 is going to be inside the parentheses.
Yeah, I get that. So that's fine.
Okay. Yeah. What is 125 squared?
The square root, or like, what is 125 times 125?
Yeah, that. I don't know.
15,625.
15. Okay, so it's going to be 1.5625 pi r squared. Now, do you see the old expression somewhere in here?
Yeah, the pi r squared.
This is the old one, right? So just plug that in there. So area new is 1.5625 the area old, which means that the new circle has an area which is 56.25% more than the previous one.
But so wasn't it 15,625? Why'd you put it as a decimal 1.5625?
Because it was in percentage. So when you square the 100 in there, that also becomes 10,000. 125% is 1.25.
Yeah, okay, so.
So the basic idea of proportion is to get the old formula in front of the new formula. If you will do that, you've done the question. Area of a rectangle is length times width.
Times height, yeah, I know that. It's very simple.
Yeah.
Sir, I'm kind of lost here.
Well, let's try to do this.
Just say that.
Basically, there are two things changing here. That's why you might have a problem. All right. So let's see. The old area is length times width. Whatever the length is, whatever the width is, it's there. And length of a rectangle is increased by 20%. So what's my new length? It's going to be 1.2 L. That's my new length, right? And my new width, that's going to be 0.8 of the old width, right?
Hanji, sir.
Yeah, makes sense.
So just multiply them to get the new area. So that is 1.2 times 0.8. That is 9.6 or 0.96. 0.96 times LB, which is my old area. So my new area is what percentage of the old area?
It's 96%, so it decreases
96%.
4%.
Exactly. So it has decreased by 4 because the question was asking how is it decreased? So it's decreased by 4. Okay, let's try another question. This might be a little tricky, this one. Come on, shouldn't take this long.
Would it be a fourth? A fourth B.
Yeah, it is. It is 1/4. Yes. Moiz, what did you get?
Sir, मुझे नहीं समझ रही है.
Okay, let's do it. So the original formula is given to us. Now, one mistake that students you might do, and I told you not to do it. यहाँ पे मैंने बताया था कि don't mix these numbers. The original number है ना उसको पढ़े रहने देना. So for example, over here 9 is there. Just keep that 9, however it is. All right, what's changing? If the distance between two particles is doubled, that's what's changing. The distance, the old distance is r, but the new distance is 2r. Everything else is the same. How does the fraction force change? So original force, old one is 9q1 q2 over r squared, and the new one is going to be 9q1 q2 over 2r whole squared. And now just simplify this. So 9q1 q2 over 4r squared. And yeah, this is my original one. So I'll just say it is old, my new one.
किया था.
क्या?
मैंने यही किया था, मुझे बस समझ नहीं आ रहा था कि मैंने क्या किया.
ठीक है, आप समझ आया?
Yeah.
ठीक है. Now I'm going to take a tricky question, and I'll give you a couple of minutes to attempt it, and then I'll explain anyway whether you do it or not.
सर आपने ये फोल्ड क्यों लिखा हुआ है?
F-O
क्या मतलब?
Force old, original value.
Oh, अच्छा, sorry.
No problem. Yeah, do this one. This is a tricky one.
So would it be C?
Let's see. Nope. I don't think it's C. I haven't solved it though. I'll have to see.
सर इसका आंसर B है.
नहीं, B भी नहीं. Okay, so I'll walk you through it. Here's the thing. The volume of a cube is tripled. The new volume is 3 times the old volume.
Yes, sir.
Okay. They haven't told us. Usually, what were we doing? In all of the previous questions, we were finding this number. They've already given that number to us. So we have to work backwards. So tell me one thing. It's a cube. So the cube, its volume is basically, if the length is x, the volume of a cube is x times x times x, which is x cubed. Right? Which means V mu is basically 3 times x cubed. And if you want to make sure that I get the factor. There's some number that's multiplying with the original value. What number would I multiply to get a cube? How do you bring this inside the parentheses?
मल्टीप्लाई करके
नहीं, parentheses में उसको लेके जाना है. And remember that there's a cube there. How do I move 3 inside? Surds में हमने किया था ये चीज. When we had square roots.
Sir, we did square cube on both sides.
I would square this thing when I move it inside, right?
Yes.
Or the other way around, square root लेके बाहर लेके आते हैं. यहाँ पर उसको अंदर लेके जाना है. That means उसको cube root लेके मैं अंदर जाऊंगा. So my factor is cube root of 3, which is, what is that? It's not 33. Can you figure it out? Calculator पकड़ो. What is cube root of 3?
1.44224.
So that means it has increased by 44%.
So I didn't get this that much because I didn't know the formula for that.
Oh, okay. How did you do it?
Sir, honestly, I did something really stupid now that I'm looking back at it.
You just divided 3?
No. I said the length of each side. So I counted the sides in a cube. And sorry, not the sides, the faces of a cube. So I did 6 times 33, which was 198. Because I read it as doubled, not tripled. So I was completely wrong in my judgment there.
It's interesting how you think about these problems.
सिर्फ मैंने नहीं थे वो जो पहली सेंटेंस से गलत पढ़ लिया तो आई थॉट कि इनिशियल जो उसकी होगी वो होगी 3 क्यूब तो उसको ट्रिपल किया तो 3 रेज़ टू द पावर 27 आ गया न्यू तो उसको मैं परसेंटेज तौर पे मैंने किया परसेंटेज इंक्रीज तो मैंने किया 27 माइनस 3 डिवाइड बाय 3 into 100 तो मेरा 12 आ गया था इसलिए मैंने आपको कहा था बी.
How do you get 12?
27 minus 3 divided by 3.
That's 8.
200. नहीं सर मैंने ऐसे ही कुछ किया था तो
Do you get this approach? This is the same one we use in search.
जी.
So yeah, I think that's it for today because the third one is going to be much longer than this, so I don't want to push you for that.
चलिए ठीक है सर.
ठीक है, but I'm here, and if you want to practice the remaining questions, I'm here.